Hey everybody, this is Pete C. with Team Cosmos. I started recently working on a 250-pound robot, or maybe 220-pound robot, I'm not sure yet. Probably 220 pounds, so I can keep competing at things like robo games and whatnot with it if BattleBots doesn't happen. But picked up a few new things, much larger scale than what I'm used to dealing with, and I thought I'd give you a quick tour of some of the cool new toys I have. Here we have a very large brushless motor. This is a Turnigy SK3 6374. This thing's huge. It's almost the size of a Coke can. Much larger than what I'm used to dealing with. I put it on a little quick mounting plate here for test purposes. But it's weighs about 2 pounds. Wants about a 12S battery powering it, so up close to 50 volts. So much larger than the stuff I'm used to dealing with. To control this thing, I'm looking at a VESC for Vetter ESC. It's an open source ESC for brushless motors. Seems to have a lot of support in the skateboarding community for powered skateboards. It does about 60 amps continuous and 240 amps for a short period of time. It's got this big honking connector on there, not what I'm used to. I'm definitely having to buy a bunch of new connectors because it's all larger than the 30-pound and 12-pound stuff I'm used to dealing with. This thing's pretty interesting because there's a bunch of different ways you can control it. There's typical RC type of connector here, so you can do PPM kind of control out of a receiver. This is a CAN bus, which is what I'm planning on using. USB port for configuring it and getting data out of it. And there's a bunch of other things on here also. There's an adapter so you can use nunchucks from a Nintendo for that's what a lot of the skateboarders use. There's also a UART on here and a couple other things that I haven't explored too much. So far it seems to be working well. Seems like a pretty cool thing. It's about $100 if you buy them online. There are a bunch of different people sell them, even though it's an open source product. There's a lot of options out there. Some a little dodgier than others, so you got to be careful and read up on who you're buying these from. In order to control this, I'm going to use the CAN bus, which is a kind of an automotive standard that allows you to communicate with a lot of industrial devices. This supports CAN bus and a couple other devices I'm hoping to put on a larger robot. It's also going to want to talk with CAN, so I decided to use the CAN port on this. In order to talk to the CAN, I bought this CAN bus shield. I believe this is a Seed Studios CAN bus shield. It is pretty straightforward. It kind of has the form factor of a classic Arduino. So I have a red board here, Arduino Uno compatible. It just plugs on there as you'd expect. It also has a bunch of different ports. You can use it to talk to your car. There's all kinds of I2C and serial ports on this thing as well. But I'm going to use the CAN bus high and CAN bus low lines on this little adapter here. So most of this is going to go unused, and it seems to be a little overkill for what I need. In the short term for testing, I have this additional Arduino shield, which will allow me to change some configurations and play around with the throttle and things like that, just as a quick and dirty input kind of mechanism. All right, I've got everything hooked up. I got my motor here kind of clamped to the desk as well as I can. These things really want to jump around, so you gotta make sure that's nice and tight. Here's the VESC. I got it plugged in the Arduino brick here. It has the Seed CAN bus on there, the joystick, Arduino, all that good stuff. Got it all plugged in. Right now I have this thing running in current mode, which means you can say I want you to use this much current to turn the motor. This basically equates to saying this is how much torque I want to apply to the motor. So as I move this joystick around, you can see the motor spin up and spin down pretty quickly. The reversing seems to be great. Has a nice smooth stop and start. There's not a lot of cogging going on. There's 3 other ways to drive this motor, or 2 other ways that I know of to drive the motor via the controller. You can use an RPM, a fixed RPM mode, and also just a typical duty cycle kind of mode. Right now I just have this working in current mode. I will play around with the other ones later. One thing that's really cool about this ESC is you get all this great data back and forth. You'll see you can see the current, the RPM, all kinds of other interesting information. You can see how much juice you've used up, your voltage, all that kind of stuff is available from the VESC. So I'm hoping to incorporate some of that into some logic in Arduino code eventually. So there's the humble beginnings of hopefully a much larger robot than what I'm used to building. It's a big learning experience. I really appreciate the information everybody's been putting out there on YouTube and in the Facebook forum. Charles Guan in particular, I've been reading his stuff pretty closely and obviously following his footsteps here a bit. So it's really great having all that data out there, and I'm hoping to contribute a little bit here and there as I learn stuff, as I take on this kind of gargantuan project. Next steps, I need to figure out the drivetrain a little bit more. I'm looking at BaneBot gearbox. It's much like Charles. BaneBots is local. They're good guys. We've worked with them a lot in the past, so I'm hoping to check that out hopefully next week sometime. This thing, while cool and easy to test with, the resolution's so low on this stick. I'm probably going to try to figure out how to hook up a normal RC receiver to an Arduino. I've done that for Angry already, so I think it's going to be pretty straightforward, but get a little finer control there and play around with that. Eventually I'm going to have 4 VESCs attached to an Arduino of some sort or some kind of microcontroller. I think I have all that figured out with the CAN bus. It's real simple. Each VESC has a different ID and you can just send motor commands to each. I obviously want to play around with the different modes of controlling the motor. The current stuff seems to work pretty well, but the RPM controlled stuff is pretty cool. You can say I want the wheels to spin at 1,000 RPM, and they have a PID controller in there, so if you apply some pressure to the motor, it will actually start to apply more amperage to the motor so that it stays the same RPM. So that's kind of cool stuff. I'm not sure what I'm going to use that for or if it's even going to be useful, but hey, it's something to play around with. I got a lot of other cool stuff going on. Not ready to reveal everything quite yet, but over time I'll pull back the covers a bit. So hope to update soon. Hopefully something more interesting to show next time. Thanks.